Hi, I'm happy to share this project. Combining what I learned from the course and my personal interest, I finally decided to do a mini research to reveal the predictability of cryptocurrency in the recent 7 years as the first project required in this course. So in the introduction part, cryptocurrency is a type of digital payment system that does not rely on banks to verify transactions. The most representative cryptocurrency is Bitcoin. The emergence and prosperity of cryptocurrency is closely connected to the financial crisis in 2008. A lot of investors at that time have lost confidence for the traditional foreign exchange market and started to look for new monetary alternatives that could be free from both external hacking and internal manipulation. To satisfy their needs, Bitcoin was invented. For a long time, people believe cryptocurrency is a safe haven, a place for investors to park their money during financial turbulence. However, last year I started to investigate whether the general belief about cryptocurrency is really true. The plot above shows the spillover effects between cryptocurrency and conventional currency from 2015 to 2022. Basically, it tells us that no matter in short term, middle term, or long term, and no matter measure using returns, exchange rate, or validity, the price of cryptocurrency is increasingly linked to the price of conventional currencies. Taking advantage of the things I learned from the course, I want to examine my hypothesis further. That is to test whether conventional currencies information can benefit cryptocurrency's price prediction. If so, from the perspective of grander causality, I can be more confident to reach the conclusion that cryptocurrencies are not safe haven in this age anymore. The data I used in this study was acquired from two sources. I got cryptocurrencies data from CoinMarketCap, the world's most referenced price tracking website for cryptocurrency price information. And I got conventional currencies historical exchange price from Trading Economics, another well-established platform that providing econometrics worldwide. A common knowledge in price prediction is that no model performs well, except for millisecond high-frequency prediction. Since I only have day-level price data from 2015 to 2022, it is impossible to really train a price predictor with good performance. In this case, I simplified it by transforming the prediction task to a binary classification task. Specifically, I only focus on predicting whether the price will go up or go down next. What I did is I labeled all days with positive returns to 1 and negative returns to 0. Because I run all the program locally, I didn't have enough computing resources to run the test on all the cryptocurrencies. In this case, I just using Bitcoin as an example to do the test in this project. So for Bitcoin, after transformation, I got 1162 positive labels and 1396 negative labels. Another thing I need to note in advance is that because I'm working with time series data, I employed a rolling window strategy to test the performance of models. I defined the time window, which is 1 year long, using this data to train the model and predict whether the return of Bitcoin will be positive or negative at the next day. After the prediction, I move the time window 10 days forward and do the same training and prediction, so on and so forth, until the time window reaches the end of the dataset. Also, because my project is about examining if conventional currencies price information provides useful information for us to predict the price change direction of Bitcoin, I need to constitute two experiments. One uses conventional currencies data and one does not. Thus, I created two datasets. Both of them have 1,500 instances. However, the dataset with additional conventional currencies information has 26 extra features about the exchange rate of major currencies in the forex market. The first model I tried is a decision tree model. I employed ID3 algorithm to do the training. 4 hyperparameters were tuned to develop the model's performance. When I use the dataset without conventional currencies information, the model with best accuracy is around 0.6. And when I feed the dataset with conventional currencies information, surprisingly, the best accuracy decreased to 0.54. I guess the reason should be on the model side. ID3 algorithm is not able to digest additional information and is confused by those extra conventional currencies price information. The second model I built is the RNN model with multiple layers of gated recurrent units. The architecture of this simple model is presented at the right side of the slide. I try to tune the number of GRU layers, the number of nodes in each layer, the drop rate, and the activation function of the model. After a long time of training and evaluation, I got the result, and it is stored and presented in the table below. For the result of decision tree, I presented the confusion matrix for the best model trained on the 2 datasets below. The best decision tree models without conventional currencies information obviously performs better. It can predict negative cases, that is, the downtrend of the Bitcoin price very well. However, the model tends to predict more negative cases than positive cases. I think it is a kind of conservative prediction strategy. For model trained on additional conventional currencies information, the performance of the model is very poor. The accuracy is around 0.54, just slightly higher than 0.5. For the for the RNN model, I first plotted the ROC curve for the best model with conventional currencies information and the best model without conventional currencies information. The AUC score of the model with conventional currency information is 0.59, and the model without is 0.52. After finding the optimal threshold for each cases, I found the best accuracy for model involving conventional currencies features is significantly higher than the accuracy of model without extra information from forex market, and the performance of RNN model is better than the decision tree model in general. This finding I got at the RNN part just implies that the information from conventional currency market does somewhat flow to cryptocurrency market. Though it is very weak, still can influence the price of Bitcoin. Of course, to demonstrate my point, I definitely need to do more experiments on that. I plan to keep working on this topic in the next project and achieve maybe some interesting conclusion at the end.